Hello all, welcome back. In the previous video, we discussed about stack implementation using array. So if you didn't check the video, please once check it out. And this video is about stack implementation using linked list, where we are going to use linked list for doing operations of stack. And here coming to this linked list, already I posted some video related to linked list concept, like basic operations, how insertion, deletion are happening, and how do we check for the like empty list. Okay, all these operations we already discussed in the linked list concept. And if you watch that video and come to this concept, then it would be easy to understand. And I suggest you to watch that video first. Coming to stack implementation, so here we'll just start with the creation of node. Like in the previous video, if you take stack implementation using array, so we created stack by using array. So simply by assigning some size to the array, by initializing an array and allocating memory for the array, so we created a stack. But coming to linked list, so we know the linked list structure, right? So a node, that a linked list consists of node, and the structure of node contains the parts like data field and a pointer field. So when you are implementing stack, at that period also you need to create a node first. So how do we create a node? This is the way we'll create a node, okay, where we need to use a class, and the name of the class is node. And if you see inside this node, we have two variables. One variable is data of type int. So this variable actually denotes this one, okay, the first field of the node, which is which holds the data value. And the next is the next variable, that is the next variable is the next, okay. And the type of the next is node. Why? Because here this next field is to store the address or to point the next node in the list. So for that reason, the data type of this variable next is node. So here this field is the next field, okay. So this field holds the address of the next node in the list, or it points to the, it links to the next node in the list. So these two are the variables, and here I just have declared these two variables. Now coming to instantiation, so when you want to allocate memory, when you want to assign value to this variable, then that is done here by using this parameterized constructor. So I'm using a constructor, so node, which is same like the name of the constructor is same as the class name, and this is a parameterized constructor because I'm passing some parameter here, and that parameter is the data value. Okay, so you are passing some data, and you are like initializing this data. This data refers to this data, okay, the class data, and you are assigning the value data to this data, okay, and you are initializing it here. And coming to the next field, always you are initializing the next field with null, because once a node is created, and the address of that node will be null, okay, until it is it gets connected with the other nodes or in the linked list with other nodes. So the address will be null only, okay. So this is how you will create a node first. After creating the node only, we can perform the other operations like insertion, okay. So you can see here I have created one more class which is called stack list, where I assign the top value as null. If we go for an array, we assigned top value as -1, because there it is an integer type of value, and there you can assign the top value as -1. But this is what a top is, nothing but the node. I'm creating a new node called top, okay. Initially the top is null, which means your stack is empty. And if you see here, this top is same like the head node which we used in the linked list. So initially we have head node, and this head node always points to the first node in your list. Same way here we have top, okay, always top points to the first node of your linked list when you're going for stack implementation, right? So this head node is nothing but the top node here in the stack. We'll be referring this as the top node, and this top node is always pointing to null when your stack is empty. So that is what the initialization done here, right? And now coming to the remaining methods. What are all the remaining methods we have seen there? First method is empty, that is to check whether your stack is empty or not. If you are trying to check your stack is empty, okay, in the linked list, then you need to check whether your top is equal to null. So if the top value is equal to null, then it means your stack is empty. You're returning true for that. Otherwise what you will do, you will return false. If the stack is not empty, then you will return false. Okay, and here what is the return statement used? The return statement used is boolean, so which will return either true or false. And what is the next method? Next method is peek method. So peek method is same, like when you want to return the top value. Okay, when you want to return the top value of the stack, then you can go for this peek method. And once you're going for displaying the top value, first you need to check whether your stack is empty or not. If it is empty, you cannot display the value because it doesn't have any element in it, right? So first you need to make sure whether your stack is like it is not empty, it has some elements. For that you are checking whether your top is equal to null. So if it is null, it means that your stack is empty. If it is empty, you're not going to return anything. Okay, just you're returning -1. Okay, otherwise what if your top is not equal to null? What if your stack is not empty, it has some elements? Then what you're going to return? You are going to return the data value of the node that is present at the top of the stack. So how do you return the value? Just by using this top dot data, because a node contains two fields. The first field is data field. You want to display the data here. So if you want to display the data of a node, you need to use this variable data. And what is a node that you want to display? That is top node. So top dot data. So what is a top node here? Top node is nothing but the head node. Okay, always a head node is referred as the top node here in this stack implementation, right? And this is what the peek method. And what is the next method? Next method is the push method. So how does a push method works? Before getting into this code, first we'll understand here how does a push works when you are using a linked list. Okay, see, as mentioned, top is the head node. Okay, now this is my linked list. Okay, this is my linked list actually, which has two nodes. The first node with the data value 10 and it is pointing to the next node which has data value 20, and this is my top node which is the head node. Now okay, I want to insert some value, like I want to insert some node here. I want to push some node into this existing list. So where do I push this node? I will push this node to the top of the stack, because both insertion and deletion happens at the top. So I want to push this into the top of the stack. So if I want to push this at the top position, okay, which means you can relate this operation with your linked list. That is, you are inserting the node at the beginning of the list. Okay, this is insertion at beginning. How did we do insertion at beginning in linked list? Okay, so this is already explained in the linked list concept. So how do you insert a node at the beginning of your list? So that is what we will see here. If I insert this new node, this is my new node I have created. Now I want to insert this node here. So what we will do basically, so I want to make change in my address field. Now it is pointing to null. My new node is pointing to null. But if I insert this here, then this will be my first node and this will become my second node. So this should point to this node, right? And this top should be pointing to this node. So I need to do two changes here. One is I need to change this link address to this one, H. Okay, and second change is I need to make this top point to my new node. These two changes I need to make. So if I do these two changes, this will be my resultant linked list. So you can see this is my first node. This is placed as my first node and it is pointing to the next node, that is H. Okay, now what is my top? My top is pointing to this node, right? And remaining these are all as usual. Okay, so how do I do it? How do we do it in the form of code? See, first thing, when you are performing insertion operation, you need to create a node first. So how do I create a node? Just by this statement, you can see I have created an object. Okay, what is that object? For the class node. Okay, we already have seen the class node, which is for creating a node, right? So here I have created a new object. Okay, I have created a new object and the object reference is new node. I'm calling this as new node. Okay, and what is the data value I pass? You can see here I'm using parameterized constructor. So where I'm passing the item value as 5. So this is my data value now. When I'm trying to construct a new node with the data value 5. So this is how a new node will be created with the data value 5 and the name of the node is new node. And what will be the address? We already assigned, we already initialized the next value as null. Okay, so it is automatically assigned as null here. Now a new node is created. After a new node is created, what is my next step? I need to change the address of this one and I need to change the top pointing to this one. Okay, so that's what happened here. New node and this address field can be referred as next. So new node dot next is equal to, and what it should have, the next should point to top, because now this is my top. Okay, as of now this is my top. I didn't change it here till now. So this is my top and this node should point to this top value, right? So that's what in this first statement, this first one is pointing to the top. And what does top has? Top has this H. So you have assigned H here for the new node dot next. Now after you did this, what is the next step? This node should be the top node. So how do you assign it? You can directly assign top is equal to new node. So top is equal to new node. If you assign this, now this will become my top node. Okay, so this is how push operation is happening. So the next operation is the pop operation. When you are performing pop operation, pop should also happen at the top of the stack. So what is the top of the stack when you are using linked list? Always the first node is the top of the stack, which means you are going to remove the node that is present at the first position at the beginning. Okay, this is also similar to deletion at beginning in the linked list. You need to delete this first node, okay, that is present at the beginning of the list, right? So this is my list, existing list, and this is pointing to the top. That is the first element is the top element. Okay, the first node is the top node. If I'm doing deletion here, this node will get deleted and the second node becomes the top of my list. Okay, so what changes you are doing here? Just you are removing this node from the list and you are making the second node as the top node, right? So that is what happened here. After deletion, this is my linked list where this second node becomes the top. Okay, remaining all same. And when you are going for pop operation, you need to check for the underflow property. That is, you cannot delete any node from the empty list, right? So you need to check whether your list is empty or it has any elements in it. So for checking the list is empty, we have the condition top is equal to null. If top is equal to null, then it means that your stack is empty, your list is empty. If it is empty, you cannot remove any element from it. You have to display stack is empty, or you can say underflow. Okay, and if the stack is not empty, then you can perform the deletion operation. But if you look at push operation, we didn't check for the full condition, that is overflow condition. Why? What is the reason? The reason is in the previous implementation, stack implementation using array, okay, we checked for the overflow condition when we are doing push operation. But here we are not doing it because array is a static memory allocation, but coming to linked list is a dynamic memory allocation. Okay, where you do not know what is the size of your linked list. You do not have any specific size for the linked list. Okay, whenever you want, you can expand the size of the linked list. Whenever you want, you can shrink the size of the linked list. Okay, there is no restriction in the size. It is a dynamic memory allocation. That is why you are not going to check for the overflow condition when you are doing push operation in stack using linked list. But in array it is not the case, because it is a static memory allocation where you have fixed size for the stack. So you cannot exceed that size. Once it is in execution, you cannot exceed the size, right? That is why you need to check for the overflow condition when you are using array, but it is not the case in linked list. So remember this point. Here you will be checking only the underflow condition, or you will check only whether your stack is empty, but you will not check for the condition whether your stack is full or overflow. Okay, and coming to this one, so if your stack is not empty, then you will go for doing deletion. And when you are performing deletion, at that time what you will be doing? So as I told, only you are going to change the top position of your list. So what should be the top position? Right? So if you are moving the top here to the second element, so how do you move it? So this is my first. When you are deleting it, it should move to the second element. And how do you move it? Just by assigning your top dot next as top, because now this is my top. What is my top dot next? Which is Z. What is Z here? It is the next node memory location. Right? So this is the link for the next node. So if you assign this top dot next as your top, then automatically your top will be pointing to this location, right? So that is what happened here. Top is equal to top dot next. If you assign this top dot next to top, then this will change its position to here, right? And before doing this, I have also done the same which I did in that like stack implementation using array. You can see first I accessed this data value. Okay, that is top dot data. Top dot data is 10. First I accessed this value. Okay, and then I stored that value into a variable called data, because in future if I want to display the value that I just have popped out, then I can use this data and I can display that. Okay, this is what the element I deleted or popped from the stack. For that purpose, what I'm doing, I'm taking the top data first, and then I'm assigning to it to a variable of type integer. After that only I'm going to change my top location. Okay, so this is what the operation for pop in linked list. That is, insertion is also happening at beginning, deletion is also happening at beginning. Now coming to the display, display is same like our linked list. If you want to display the elements of the stack, okay, you need to start traversing from the first node to the like end of the node, one by one sequentially. Okay, first this node will be visited, and then this node will be visited, and then this node will be visited until the last node, until you reaches the last node. So this is an iterative process. So for this case, for this iteration, I have used while loop. Okay, and with this while loop, I'm going to iterate over the element. So starting from top, here I have assigned my top to a new node called current. Okay, I created a new node called current, and I assigned this top to current. Now what I'm doing, I'm going to traverse this, like this is my current node. When I want to visit, the next node, what I can do, just by assigning current dot next to my current. Okay, if I assign current is equal to current dot next, which means I'm moving from this place to this place. What is current dot next? G. Where is G? This one. Now I'm assigning this one to current. So this becomes my current node now. Okay, in the same way, next time what I'm doing, again I want to move to this node. So what I'm doing, I'm assigning current dot next H to current. So now this will become my current. Right? So until when I'm going to traverse, until when I have to traverse like this, until I reaches what? Null. Until my current reaches null. I need to repeat the process iteratively. Okay, so you can check the condition here. When current is not equal to null, then you are performing iteration. Okay, how you are performing iteration? Current is equal to current dot next. Okay, you're just moving from the one node to the other node, next node, next node, next node. Like you are performing this operation. So till this condition becomes false. When this condition will become false? When it reaches the end and you are trying to traverse after the end. When the current is equal to null, then this becomes false. Right, and meanwhile here what you are doing, you are displaying the value. You need to display the data field, right? So you want to display this one, so current dot data. In the first time it will print 10. Okay, after that it will move to the next node, again it checks for the condition, then come back, then now this is my current, it will print 20. Again it comes to this place, then current becomes the next node, then again it goes and check for the condition, then again it will print current dot data. Now 30 will get printed. So likewise it will get traversed. Okay, you are traversing to all the nodes and then you are trying to print the data here. So these are all the basic operations of stack implementation using linked list.